Welcome to this lesson on constructors in Kotlin. In this video, you'll learn about the different types of constructors available in Kotlin and how to use initialization blocks effectively. Constructors are fundamental building blocks in object-oriented programming, and understanding them is essential for creating well-structured Kotlin classes. Let's start with the basics. A constructor is a special member function that is automatically called when you create an object of a class. Its primary purpose is to initialize the properties of that object. Think of it as the setup function that runs every time you create a new instance. Here's an important point to remember. Every class must have a constructor. If you don't explicitly define one, Kotlin automatically provides a default constructor for you behind the scenes. The most common type of constructor in Kotlin is the primary constructor. It's declared right in the class header, making it concise and easy to read. In this example, you can see a person class with a primary constructor that takes two parameters, name as a string and age as an integer. Notice how we use val for name and var for age. The val keyword makes name read-only, while var allows age to be modified later. This is the preferred way to write constructors in Kotlin, because of its simplicity and clarity. Sometimes you need to execute additional logic when an object is created. This is where initialization blocks come in. You can add an init block to your class to run code immediately after the primary constructor is called. In this example, the init block prints a message showing the person's details and validates that the age is not negative using the require function. The init block executes automatically every time a new person object is created, allowing you to perform validation, logging, or any other initialization tasks you need. While the primary constructor is defined in the class header, secondary constructors are defined inside the class body using the constructor keyword. They provide alternative ways to create objects with different sets of parameters. In this example, the person class has a primary constructor that only takes a name parameter. Then there's a secondary constructor that takes both name and age. Notice the colon this name syntax. This is called constructor delegation, where the secondary constructor must call the primary constructor. After that delegation, the secondary constructor sets the age property. There are 4 important rules to understand about secondary constructors. First, every secondary constructor must delegate to the primary constructor using the this keyword. This ensures the primary constructor always runs first. Second, you can have multiple secondary constructors in a single class, each accepting different parameters. Third, secondary constructors execute after the primary constructor and any init blocks have finished running. And fourth, secondary constructors provide flexibility, allowing users of your class to create objects in different ways depending on what information they have available. Let's put everything together with a complete example. Here's a car class that demonstrates both primary and secondary constructors along with an init block. The primary constructor takes brand and model as parameters. The init block prints a message when the car is initialized. Then there's a secondary constructor that accepts brand, model, and year. This secondary constructor delegates to the primary constructor using this brand model, and then sets the year property and prints another message. When you create a car using the secondary constructor, you'll see both messages printed, first from the init block, then from the secondary constructor body. This shows the order of execution clearly. Let's recap the key points from this lesson. Primary constructors are concise and declared in the class header, making them the preferred choice for most situations. Use init blocks when you need to execute initialization logic alongside your primary constructor, such as validation or logging. Secondary constructors provide flexibility and must always delegate to the primary constructor to ensure proper initialization. Finally, choose the right constructor type based on your specific initialization needs. If you only need simple property assignment, stick with a primary constructor. If you need multiple ways to create objects or complex initialization logic, consider using secondary constructors. With these concepts mastered, you're ready to create well-structured classes in Kotlin.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.